Hey guys, welcome to your 5th Godot tutorial. In this tutorial, I'm going to show you guys how to handle user input. Alright, so let's look at the path or the life cycle of an event. So your computer, you have a couple things connected to it, right? Or your console, whatever it is. You have a mouse, a keyboard, and maybe a gamepad or a joystick. Now, whenever you interact with these hardwares, what's going to happen is you emit an input event of some sort. That's the abstract term for any of these. And then that input event is passed to your operating system. Your operating system passes it to Godot, and Godot passes it to the scene tree. Now, the scene tree will pass it along a long chain, right? So remember that inside a scene you have a bunch of nodes and other scenes arranged in a hierarchy. So what it will do is, first it will pass it to the input function of all the nodes, and it does this in a reverse DepthFirst method. I'll show you that in the next slide. And then, if it's not handled, it will then pass it to the GUI input function of all the GUI classes, and if it's still not handled, it will pass it to the unhandled input method of all the nodes once again. So an event comes into the scene, it will go through every single node in the scene tree in a reverse DepthFirst order, and it will call the input function of all the nodes passing in the event, right? If along the way any of the nodes marks the event as completed or handled, then it will stop getting passed, right? But let's say it does not get handled and it keeps on getting passed, and it passes through all the nodes' input methods. Then the scene will find all of its control nodes, in other words, all of its GUI nodes, and it will pass it to the GUI input method of all those nodes, one at a time. And again, the same thing applies. As long as it's not handled, it keeps going to the next. And if it's still not handled, then if you've gone through all the controls, it will get passed to the unhandled input method of all the nodes once again. So you have these 3 layers where you can handle the input. So what I meant by reverse depth first, it's depth first, but the last children go first. So for example, I found this little nice picture that shows this. I found this on the official Godot documentation. So what you have here is a scene tree, right, with a bunch of nodes, and the numbers depict the order in which the events are passed around. So this child over here would be receiving the event first, and then this child, and then this child, and so on. And you can this makes sense because so this is the root, right, and it has 2 children. So since we're going depth first and since we're going reverse, it goes to the last child, and then it recurses. It goes to the last child of that one, and so this guy becomes your first, and then it goes back up, and it goes to the last child of this guy, which is that. If you trying to explain this is in words is a little bit hard. I think if you just look at this picture, you'll know what reverse depth first means. And here's just some examples of events, right? So if I click the left mouse button, right, I can push it down. I can push the left mouse button down. That's an event. And when I lift it back up, that's another event. If I move the mouse a little bit, each time I move it, each one of those moves is an event. That's called a mouse move event, or sometimes a mouse motion event. If I, for example, just press down the A key, that act of me pressing it down is an event. Now if I continue to hold it down every frame, that's basically an event as well, because that's called like a key held down event. You can think of it that way. And then when I finally decide to let up the A key, that's an event as well. So these are the types of events you usually see in games, and actually more generally in most GUI applications. Okay, so here's the types of events that Godot has, and these are nicely organized into 3 of the most important event handler classes. So the base class is an input event, which represents any type of input event. And then you have 3 main subclasses. We have the input event key class, which represents a keyboard input event. So this will tell you when the key has been pressed down, when the key has been held down, and when the key has been released back up. Then we have the input event mouse button event. This will tell you basically whenever a mouse button, whether it's the left, the middle, or the right, whenever it's been pressed down or when it's been released. As well as it will tell you the position of the mouse when the event occurs. And this input event mouse motion, this will be emitted every time the mouse moves a little bit. So like this, right? And this will tell you the position that the mouse moves to. And it will also tell you this nice little relative property. That tells you how much it moved relative to the previous input event mouse motion that was emitted. Quick little note here, you'll see that some of these events have both a position and a global position property. So the position will tell you the position of the mouse event relative to the screen, right? The window. And the global position will actually tell you the position of the mouse in your world, in its global position, for lack of words. So its position in the world. Now let's unwind a little bit and let's go back up and look at these classes, right? So when an input event key happens, this parameter, it gives you these three properties, right? Its scan code property, this basically tells you the key that was either pressed or released, right? The echo property is just a Boolean. This will tell you if this is true, it means it was just pressed, okay? If this was false, it means that it was pressed last frame too. So here's how you can distinguish whether a key press was a first press or if it's a press that's a hold, right? So in other words, how do you distinguish between a key press and a key hold? Well, you can look at this echo variable. And then last but not least, it's this Boolean called pressed. And this will tell you whether it was actually pressed or released. So if it's true, you're talking about a key press. And if it's false, you're talking about a key release. So notice that the input event key tells you, like, this is emitted for both key presses, key holds, and key releases. And you can find out which specifically it was by looking at these properties. The input event mouse button tells you a couple things as well. So it will tell you the position relative to the screen or the position relative to your whole world that the mouse was at when the event occurred. The button index property, this will actually tell you the actual mouse button, whether it was the left, the middle, or the right. It doesn't tell you whether it was pressed or not, it just tells you which button was at play. And then this last Boolean, this is the one that will actually tell you whether it was pressed or released. If it's true, it means that whatever mouse button was pressed. If it's false, it means that that mouse button was released. And then we have the input event mouse motion. Again, this one will tell you the position relative to the screen and relative to the whole world. And it will also tell you this relative property. Basically, this tells you how much the mouse moved since the last input event mouse motion. It's a pretty useful little convenient thing. Okay, so a little quick recap of what we just covered, and then I'll actually go ahead and implement a little practice thing, okay? So, input event path, right? It starts at the hardware, whether that's a mouse, keyboard, gamepad, joystick, whatever. Gets sent to your operating system, which then sends it to Godot, which sends it to the scene tree. Now, a scene tree, in a reverse step format, it will first send it to all of the input methods of all the nodes in the scene tree. If it's still not handled, it will send it to all the GUI input methods of all the control nodes, so the GUI nodes. If it's still not handled, then it will send it to all the unhandled input methods of all the nodes once again. So you have this passing around of all these, of the event through all the nodes, the various functions of the nodes. And anywhere along the path, if the event is marked handled, it doesn't keep on going. That's the end of it. So to actually handle an event, this I haven't covered yet, but we're going to see it in example. So you can basically use one of these two functions, right? So if you are handling an event from within the input method or the unhandled input method of a node, then you use getTree.setInput as handled method. That will set the last input event as handled, okay? Now, if you're handling the input as a GUI, so if you're handling it through the GUI input method, then you have to call your accept event method. I don't know why they did it this way, but this is just the way that it's done. So to handle an event, all you have to do is figure out at what level you want to handle it, right? And then go ahead and implement one of these methods in your node, and then mark it as handled when you're done with it. Simple. So let's go ahead and actually do that in practice. So what we're going to do is make a little Godot project where we're going to have a button, and we're also going to have a little sprite. And then we want, first of all, if they click on the button, we want the button to take the input event. But if they click anywhere else, we want the input event to go to the sprite. And all the sprite will do in response to the input event is just move to the place that it was clicked. But the button, when it's clicked, we're just going to print something out. This is just to show you and to prove to you that, this is how the flow goes, right? All the input methods are called of all the nodes, and then all the GUI input of all the GUI, and then all the unhandled input methods of all the nodes again. So this gives you a way, if you implement an input method, that means you will get the event first. This gives you a way of capturing the event even before it goes to any GUIs. But generally, for your regular nodes, you want to implement the unhandled input event because you want the event only if the GUI hasn't used it, right? You want to give the GUI usually priority. So that's what we're going to do. We're going to make sure that our own sprite node, it implements the unhandled input so that it gives a chance for GUIs to get the event before it gets it. Now we got a plan, let's go ahead and execute it. Create a new folder. Alright, I'm going to call it tutorial 5. Go ahead and launch Godot. Alright, create a new project. I'm going to put it on the desktop. Oh my gosh. Tutorial 5, create and edit. Alright, we got a new scene here. We're going to go to the 2D editor. I'm going to add a root node. So I'm going to add a generic node here as the root, and then I'm going to add 2 children. So I'm going to add a sprite child, and I'm also going to add a button. So that's a control. So as you can see, this little viewer shows you the controls all under this control category. This viewer shows it to you in like the same way that the class hierarchy actually is. So, alright, we've got an unsaved scene. Let's go ahead and save it. Control S. I'm going to save it in the root of our project, and I'll just call it, you know what, let's just call it myscene.tscn. Okay, and for our sprite, we're going to give it this icon.png, and we'll put it somewhere here. And for the button, let's set its text property to some text. There we go. And we'll put the button right here. Okay, so once again to recap our plan, if the user clicks on the button, right? Think about it. The hardware will generate a mouse clicked event, send it to the operating system, which sends it to Godot, which sends it to the scene tree. And what does the scene tree do with it? It will go through all the nodes in the scene, right? In a reverse depth first fashion, and it will give it to their input method. None of these guys have the input method overloaded, so the event is going to flow through that without a problem. Then it's going to go and give it to the GUI input of all the controls. Well, we only have one control in this scene hierarchy, right? It's this guy. And his GUI input, if it will check if the click was within its bounding box, and if it was, it will emit a signal called button clicked, or just clicked, I think. It will emit that signal, and then it will mark the event as handled. So it takes click events as long as it's on top of its bounding box. Now, let's say that we didn't click there. Let's say that we did not click there. Let's say we clicked over here. So this guy will not mark it as handled, And now it will, remember, it will go through all the nodes again in a reverse depth first fashion, and it's going to pass them through their unhandled input method. And the plan is for this guy, we're going to implement the unhandled input method, and we're going to basically move him to wherever it was clicked. Okay, but first of all, let's go ahead and take care of this guy. So if this guy is clicked, right, he's going to emit that clicked, or I think it's pressed. Let's check that. I like to check things really quick. So Godot button, we're going to look at the documentation for the button class. And it has a, let's look at its signals. I'm sure somewhere down here. Let's see what it inherits. Base button. Okay. So pressed. This signal is emitted every time the button is pressed. So we're going to listen to the pressed signal. All right. We're going to attach a script to the, not to the sprite, we're going to attach a script to the button. We're going to make it C#. I'm just going to call it button. We're going to create it. I'm going to launch VS Code because I like using it to do my editing. Okay, so I got VS Code up here. Now I'm going to edit this file. Okay, so here's the script for our button. Now, in its constructor on the ready function, which is emitted as soon as the button enters the scene tree, right? Remember that. What we're going to do is listen to its own clicked signal. So I'll do this and then I'll just show you, because I've done this many times and I feel like I don't have to do this constantly. So I'll just write code that connects to the button's basically pressed signal, and then we're just going to print a message that the button has been pressed. Let me do that and then I'll show you. Okay, so as soon as the ready function gets executed, so as soon as the button enters the scene, so in other words, as soon as it's kind of constructed, you can think of it that way. What we're going to do is we're going to connect to the button's pressed signal, and the target method is on this object itself, and the name of the method is called onPressed, so this function. So this function gets executed when the pressed signal is emitted by button. We're simply going to emit, wow, having difficulty with words today. We're simply going to output a message, basically, when the button is pressed. Okay, now let's go take care of the behavior for the sprite. So let's go ahead and attach a script to it. C# sprite.cs, that's fine. And here we're gonna sprite.cs. Let's clean up this junk. Okay, so in its ready function, so as soon as the sprite enters the scene tree, we don't want to do anything here at all, actually. What we want to do is implement the unhandled input method. So remember, that method gets called after the GUI has a chance to handle the input. So we'll do public override void unhandled, and the IDE will help us here. All right, so we're going to get past the event. What we're going to do is we're going to check the type of the event and see if it's a mouse click, right? So if the event is input event mouse button, we're going to call it button event. Okay, let me finish the rest of this code and then I'll read it to you. Okay, that really wasn't much more code, but anyways, so the unhandled input method gets called. It passes you the actual event. Here we're seeing if it was a mouse button event, and if so, we get the global position of the button event, and we set that to the position of the actual sprite. So every time you click somewhere, we're going to move there. Actually, I made a slight little mistake because right now this could be a mouse click or a mouse release. I want it only on the mouse click to move. So I'm going to make one more check. If the button events that pressed equals true. Well, I don't have to do that. It's just pressed. So if it is a mouse event and if it's a press event as opposed to a release event, because if this is false, it's a release event, then I'm going to move the sprite to the global position of the button event. And that's it. Let's test this out. We'll run our scene. Alright, so as you can see, when I click anywhere on the screen, the guy moves there. But if I click on here, this guy shouldn't move at all because the input should be handled by him. And remember, what the button does by default, it checks if the click is, in its bounding box, and if so, it then just emits that, button press signal if it recognizes that it's an actual click. So let's give it the event. And if you look down here, you'll see that indeed the button is the one that got the event. Okay, so let's do a quick recap. Okay, so events are generated by hardware, passed to the OS, passed to Godot, which passes it to the scene tree. The scene tree will, in a reverse DepthFirst format, pass it to all the nodes' input methods, then through all the GUI nodes, in other words, the control nodes' GUI input method, then again through all the nodes, but this time the unhandled input. And as it's doing all this passing around, at any point, if the event is marked as handled, it stops getting passed around. So how do you mark an event as handled? Well, there's two methods, this one and this one. If you're marking it handled inside the input or the unhandled input methods, you use this method right here, set input as handled. If you're marking it as handled in the GUI input method, you just use your accept event method. So to handle an event, generally you just do this, right? You implement either of these, any one of these functions, and the one that you want depends on the level at which you want to catch the event. So do you want to catch the event before even the GUIs get it? Or do you want to give the GUIs a chance and then catch it after all the GUIs have done whatever it is that they want to do? So you implement your method and then you simply handle it at the right time. And that's it. So that's it for this tutorial. I'm going to put the slides also because I feel like these slides will be pretty useful. I'll upload them and put a link in the description. As always, I have been uploading the code for these tutorials so you can take a look at that as well. Thanks for watching, and I'll see you in a future tutorial. Bye bye.